we're asked to find the derivative of y is equal to x squared. Usually, when we're asked to find the derivative of a function, what we usually use is the power rule, which is to take the power over the variable down to multiply with the variable and decrease the power by 1. Thus, you get 2x. That is the derivative of y is equal to x squared. However, these are conventional methods. What is actually happening in the background? Let's see. Let's say we have a square. Its length is x and its width is x. And usually, the area of a rectangle or a square is its length times its width. Thus, let's say area is y. So y is equal to x times x, which is x squared. And so this is the area of this square. Now, let's say that, for example, we increase, let me increase it a little more. We increase both sides, we increment both sides by a certain value. We increment both sides by the value dx, As we can see, x, the length which was originally x, has now been broadened or incremented by the value dx. So the new length of this square will be x plus dx. Same way, the width will become x plus dx. This is a new broadened width, this is a new broadened length and width of this square. The derivative, which we're supposed to find, is the area of these incremented sides. How will you find that? It's obvious. Take the area of this whole enlarged square and subtract the original area, which is x squared, from the new enlarged area, which is y plus dy is equal to x plus dx times x plus dx. Note that dx is the increased or incremented length of these sides, which was originally x. We have increased the length of this side by dx. Then what is dy? We know that y is equal to x squared. Y is equal to x squared. Dy is the change in y. The overall change in y is dy. The overall change in x. This added area, the added area is dy. This is what we're trying to find. Next step, y plus dy is equal to x plus dx whole squared. Expanding this expression, we get what? Y plus dy is equal to x squared plus 2x times dx plus dx squared. Subtracting both sides by y, which, note to self, is x squared. We can replace y with x squared and subtract both sides by x squared. So then x squared plus 2x times dx plus dx squared minus x squared, which was originally y, and here we are subtracting both sides by x squared. So this x squared and this x squared cancel out, and we're left with dy is equal to 2x times dx plus dx squared. But this is not our final differentiated form. We can see that both terms, 2x times dx and dx squared, have a common factor of dx. So dividing everything by dx, we get dy over dx is equal to 2x, wait, is equal to 2x times dx all over dx plus dx squared over dx. So dx cancels out in the first term, and we are left with dx as our second term. So the final form is 2x dy over dx is equal to 2x plus dx. But this is not the final differentiated form. This is not the derivative. Why are we excluding dx if it's already there? This dx is in relation to this tiny square. This tiny square in the corner is dx squared, which we've calculated right over here. Why aren't we including that in our differentiated form? Well, to do that, we must limit this expression. If we limit 2x plus dx, where dx is limited till 0, this means that the closer dx gets to 0, the more exponentially smaller dx squared gets. For example, if dx is equal to 0.001, dx squared is going to be 0.000001. So the smaller dx is and the closer it is to 0, dx is going to be exponentially smaller. This is why when dx approaches a very minimal value, dx squared gets infinitesimally small. Infinitesimally small. And in this case, it vanishes. If it gets infinitesimally small, that means the infinitely smaller dx gets, dx squared at that point vanishes. You cannot see it at all. This is why dx squared becomes negligent and is excluded from the final derived form. This is why when we limit 2x plus dx, where dx is limited to 0, we are left with 2x only. In the end, y dy over dx is equal to 2x. And remember, this area, the new incremented area, is going to be the derivative of the original square, because it is an instantaneous change in value, in area, in length, in width. This is an instantaneous change. Dy over dx is an instantaneous change of the original area. So whatever area dy is, or dy over dx is, that is going to be the derivative.